We have the cesspit and the tapeworms. Focus on today the nematodes, which is one of the largest phyla that exist on this planet, and it's one of the most, if you say common, I think it is the most common animal phyla on the planet, with all earth-dwelling nematodes, not parasitic, that we have. A few of these are parasitic, and today I will focus on gastrointestinal nematodes. Gill infection, maybe some of you seem to have had some gill yesterday, they are still common in many parts of the world. Some of the most prevalent species are, we have hookworms, which is a whipworm. The data shown on the slide here are, give me a second, I will try to see if I can get the pointer here. Yes, spotlight. Examples from one school, and then the other one was more a mix. About half or a little bit less carry at least one intestinal worm. The highest burden of worms you also find in areas where other frequent infections are highly frequent. When it comes to worms, and this is what I'm coming into, it's sort of, as I told you, reinfection is common, but also some people are predisposed to worm infection. And this also goes for animals, actually. So we can say that we have some individuals that are a little bit more wormy, and we have individuals that are non-wormy. They are not so easily infected with worms, and typically have lower burdens of worms. And the figures here, they show correlations between how much the worm load was before a deworming program and how much it was after deworming program. So on the x-axis is sort of the initial burden of worms or eggs, and there is a very nice correlation with what is found again 1.5 to almost 2 years later. This is dependent on immune responses, and there is a correlation with changes in immune parameter that goes with worms. That is antibody profiles, and there is T-cell responses. And dependent on the T-cell responses that are evoked, there are different susceptibilities to worms. So T-cell responses that are associated with control of worms are typically these Th2 cells and generation of Th2 responses. In my country here in Sweden, this is typically linked to allergy and asthma, whereas in other parts of the world, these responses are important to control extracellular parasites like worms. Whereas if people have high levels of interferon gamma responses, that may predispose to helminth infections. This is just a summary. I will not go through it in detail of the type 2 responses that hallmarks the worm infection. And what one can find is typically eosinophil activation, and this goes for all worms. Mast cells are activated. We find alternately activated macrophages and antibodies hallmarked by IgG4. And we also find activation of both Th2 cells and also regulatory cells. All these responses are designed for things. Reaction of phenomenon, and that is the IL-4 will increase smooth muscle contraction. It will also contribute to epithelial cell turnover and mucus production, all designed to sort of get rid of the intestinal worms. But the worms also drive these cells, the regulatory cells, and those are designed to dampen all kinds of responses. So different T cell responses can counteract each other. And here we have worms driving Th2 cells and regulatory cells, which will have dampening effects on other type of T cells required to control other types of infections. So if we look at infections that reside intracellularly inside macrophages, like Mycobacteria, Mycobacterium tuberculosis, and all the Leishmania species, and also some other species like Salmonella can dwell in macrophages. They are controlled by Th1 responses. And then we also have other bacteria which can be controlled by Th17. And this can be then, at least theoretically, dampened by helminth infection. And then maybe the most important is the regulatory response that is evoked, here represented as regulatory T cells, but we also have alternatively activated macrophages, and the IgG responses that worm drives, the IgG4, are also more of a dampening sort. And this graph shows how responses to a worm will actually, you have an acute infection, here we have an acute Th2 response, but then it will decline with time. And this is typically seen in helminth infections. If one then takes away with cytokines like interleukin-10 and TGF-beta, which have this dampening effect, one can retrieve the responses. So in general, to survive and not to damage tissue, the worms have these effects, and this is typically seen with chronic infections. So, what are then the implications for this when it comes to other infections? Will worms then be something that can drive an infection from subclinical infection with self-cure towards more clinical disease? I'm sure many of you have seen this slide before, looking at tuberculosis prevalence of the world. Tuberculosis is I still think, the single organism that causes most deaths, well, exception from COVID now lately, around the world. In Kenya, it is quite a high prevalence of Mycobacterium tuberculosis, with about somewhere around 240 something per 100,000 on average. And as I said before, high burdens of tuberculosis geographically overlaps with total infectious burden, and typically also a high prevalence of helminth. So in countries where we have high infectious burden, there are also worms, and they potentially then could affect other control of other infections, such as tuberculosis. This was a study now done quite a long time back, but I still think it's quite relevant. So this was comparing, just looking at stool samples from people with tuberculosis and those not. And what they found was that TB patients have a higher percentage of them are carrying worms. They also carry small worms, and with an odds ratio of about 4.2, which is relatively high, I think. Showed that in an experiment where they vaccinated volunteers with BCG, and they did this before a group that was dewormed,
albendazole treatment prior to the vaccination, whereas those cytokines linked with dampened immune responses were reduced. So giving us an indication that there may be a link. But in human studies, it's not so easy to prove causality. One can prove connections, but to show that one is causing the other is difficult. And also, many of these studies have been relatively small. There have also been other studies which have not been as conclusive. So what we decided was to set up a model. And here we used the worm model Helicmosmitis polygyrus, and I will go, it's, to roughly say, it's an intestinal nematode that lives only in the intestine. It has no root outside the intestinal tissue. It drives Th2 cells, and it becomes chronic and drives regulatory responses.
Mice that were infected with this worm are more susceptible to both mycobacteria and leishmania, here shown looking at colony-forming units in the liver, or Leishmania donovani parasites in the liver. This was done after an IV injection. They also had lower levels of INOS, which in the mouse corresponds to the reactive oxygen metabolites. In humans, important for killing of mycobacteria or leishmania. And maybe a little bit surprising, they had fewer or smaller granulomas, maybe indicating that the granulomas are not forming properly. We were particularly interested in peripheral effects of gene infections. And this is because of that, for example, mycobacterial vaccination, BCG vaccination is given in the skin, and we also measure PPD reactions in the skin. And vaccines are also, all of them are either given orally or most are given intramuscularly in the periphery. So we wanted to see what had happened in other parts of the body. In the mouse, instead of doing this PPD test, we can do a measure footpad swelling. And what we saw here was that mice that carried worms had reduced footpad swelling as compared to those that did not carry worms. They also had fewer, and this is looking at specific T cells, fewer mycobacteria specific T cells in the tissue where the PPD reaction was given. Here we look in the ear because it's difficult to do in the foot, as compared to the ones that did not have worms. If we look at leishmania, we saw a similar effect with that the ones that had worms had a reduced swelling as compared to those that did not. So what could this sort of mean in the real world? If this is true, presence of worms could potentially influence the size of the DTH response. And it's something that also should be considered in cutoff of tests, that it may be slightly different if one carries other infections. Interestingly for us, when we looked more in detail into this, we found no clear evidence for that our responses, the muted responses, were connected with regulatory T cells or elevated Th2 in this case. And we asked, so what could it be then? What is causing the muted response? When one gives an infection or an immunization in the skin, there will be sort of an expansion of the draining lymph nodes. And this is the site where the sort of initial interaction between antigen presenting cells and T cells driving the immune response will happen. But we found again that the expansion of the lymph node was muted when we had worm-infected mice as compared to non-worm-infected mice. I was also linked, I skipped this slide actually, due to time. And this is how actually we could see that when the lymph nodes sort of were found to be smaller in all peripheral sites, we saw a progressive atrophy of superficial lymph nodes in our helminth-infected mice. And this was linked to sort of a loss of actually lymphocytes, both T cells and B cells, more T cells over B cells, and more CD4s over CD8s. And when we look at the lymph nodes, if we just sort of summarize it, comparing the naive mouse and the worm-infected mouse about a month after, we have shrunken the lymph node, the peripheral lymph node size, quite substantially. What we could see was that as the peripheral lymph nodes shrunk, the mesenteric lymph nodes, which also are a site draining an infection, and in this case the worm infection, expand. So we proposed an idea where the expansion of the mesenteric lymph nodes draining the site of worm infection occurs at the expense of other lymph nodes, suggesting that we have a limitation in size. To summarize this first part, so worm mice that have H. polygyrus are more susceptible to systemic Th1 pathogens, weakened DTH responses, and that we see an atrophy of distal lymph nodes. But we were interested in also what occurs in the skin. And the skin is an organ that is populated with immune cells normally. We find both CD4s and CD8 cells. As I showed you before, underlying H. polygyrus worm infection dampen the skin responses to mycobacterial antigen. And we had fewer Th1 than in this case cells in the worm-infected mice when given a whole cell lysate of Mycobacterium tuberculosis. We had fewer cells, so both frequency of the cells were fewer. However, when we looked at the total CD4 cells, to our surprise, we found more in the worm-infected mice. We also found that in the skin, in this non-immune tissue, CD4 cells are deposited, and that this is worm-specific CD4 T cells, shown in this figure where we have the worm-infected, and we look at the foot pad swelling now in response to the worm. And if we look with MHC class 2, which is on the antigen-presenting cells, we can mute the response. We also found that the cells in the site produce Th2 cytokine interleukin 5 in response to worm antigen. We also found that these cells persisted in tissue for a very long time. So even while numbers of cells in the ear were normalized, we retained a population of Th2 cells in the skin. So what this told us was that if we have a worm infection, we remodel a dynamic T cell pool in the skin. So with before worm infection, having one composition of the skin. During worm infection, we get another with more cells in the skin. But after infection, some of these worm-specific cells are still present in the skin. So, to summarize, we can see that the lymph node atrophy also, I didn't show this, is something that is reversible, and where the worm-driven Th2 responses accumulating in the skin are much more persistent. I would give it some thought here, but because I think if one has a chronic worm infection for a very, very long time, this probably also would have implications that are more lasting. So not to take up any more of your time, we have, I didn't show everything, shown in different studies that gastrointestinal nematode infection have inhibitory or mute various responses, such as T-cell priming, control of mycobacteria and Leishmania infection, DTH responses, that it shows they also influence dendritic cell migration from
Dr. Kido, do you have any question?
My mic is that on what?
Oh. Is that from Kenya? No. Uh-huh.
Yeah. Can you hear me?
Any question from the floor?
We could take questions at the end.
Oh, somebody come.
This Professor
It's very difficult, the question or just controlling the voices.
Can I suggest you in the room, I've experienced this, if you only have one
Yes.
one computer
So just unmute on the unmute or mute.
mute.
Just mute. And because there's so many people who have joined through Zoom and yeah, that will have challenges. But which one can we now use to speak? Because we can check, this one is even enough. We can take the questions at the end.
Ines, are you okay?
Can you hear me? Because this one is not.
Okay, so I have a question, something. So you mentioned the co-infection, helminths, and other infection. You mentioned about TB, but how about others? For
How about
example,
malaria?
For example, malaria, yes.
I think with malaria there are studies are divergent, I would say. Some indicate that there may be a link with sort of having worm infections and that it may predispose to malaria, whereas others show no connection. It may be one, I think it can depend on which worm that one looks at, and also how you address how you do the studies to see if
because malaria, much of clinical symptoms are also immune-mediated and strong inflammation. So one can see that this balance between sort of dampening immune responses and allowing the infection to persist. In the case of malaria, the clinical outcome may sort of, what can I say, even out itself, maybe would be. But I would guess that it would probably predispose to sort of establishing an infection. That would be my guess. And I think it would be, I don't know if anyone has particularly addressed the stages, the liver stages, for example. If you have a worm infection, if they would replicate faster or better following an infection. That's where I probably think you would see the effect. Then in clinical malaria, one could also speculate that having worms dampening effects could have some potential sort of positive effect of sort of overactivated immune system. But I would guess that it would probably push it a little bit towards being more susceptible. But it also depends on the worm, I think.
Okay, thank you very much.
Yes, Professor.
Other questions from the
Professor Satoshi Kaneko, thank you for guiding us. We couldn't speak that time. Well, what we are trying to do to save time, probably we can have all the speakers, and then at the end of it, we can take the questions if we have enough time. Thank you.
So I should move to our next speaker. Yeah?
Yeah.
Thank you very much.
Thank you very much, Dr. Nyland. So I want to move the next speakers. Thank you very much. Next speaker, from now, so we are going to invite some professors and doctors from the research universities. First one is Dr. Kajihara from Hokkaido University. Our topic is surveillance of zoonosis in Zambia. Dr. Kajihara, can you start?
Thank you for introduction. Is slide shared properly?
Yeah, but not the presentation screen. This is just this is okay.
Thank you very much. So can I start now? Thank you for introduction. I'm glad to be invited this interesting symposium. This is Masahiro Kajihara, Associate Professor in International Institute for Zoonosis Control in Hokkaido University. Today I'd like to talk about our activities for the surveillance of zoonosis in Zambia. So our International Institute for Zoonosis Control was established in 2005 as a research center for zoonosis control. But last year we organized our research center to the International Institute for Zoonosis Control to identify natural hosts and transmission routes of zoonotic pathogen is one of our major missions. And then also the education is also important to make a global leaders for the zoonosis control experts. As you know, the zoonosis control should be conducted under the One Health concept. One Health concept which is established a more interdisciplinary and cross-sectional approach to preventing epidemic or exotic disease and for maintaining ecosystem integrity. So in this, this is why it is quite important, not only humans, but global wildlife and livestock health surveillance networks should be formed. So this is why we have a strong collaboration with the University of Zambia School of Veterinary Medicine, UNZAVET, in Zambia. We have a very long collaboration history. We have continued the collaboration like 39 years. And we have made some MOU between UNZAVET and our institute in 2007, and then periodically we are renewing this MOU. Currently, we are running the two major projects The first one is the development of research and human resources for the control of zoonosis under the AMET project. We are forming a tripartite collaboration between our institute and UNZABET and National Institute of Infectious Diseases. The other project is under SATREPS. The project name is Epidemiology of Zoonotic Virus Infection in Africa. This is supported by JICA and AMET. So by like this kind of project, we have actually established the Hokudai Center for Zoonosis Control in Zambia. This center have created 2 and 3 laboratories. And we have enough capacity to perform a different kind of a variety of experiments required for the infectious disease study. And we also have a mobile laboratory as well. With using this mobile laboratory, we can conduct a field sample analysis at the site. Also, the laboratories in UNZABET are also innovated under the SATREPS project like this. So not only equipping the laboratories, we are continuing the education of the Zambian counterparts. So far, approximately 30 people are taught the PhD course in our Hokkaido University. So today, among the wide range of our research activities, I'd like to talk about the hemorrhagic fever virus surveillance activity. At first, I'd like to talk about our virus disease surveillance. First, our achievement is the West Nile virus research. This virus causes a fatal neurological disease. It's approximately 300 feet higher longitude. This is a major vector of the Crimean cold hemorrhagic fever. So among them, we have found 11 positive samples, and phylogenetic analysis indicate the strains are to the Africa 3 lineage together with the different other African strains. So similar to West Nile virus, Zambia has never had a record of CCHF. However, now that we should cover the Zambia red as well. So like this, the epidemiological study of CCHF in Africa should be conducted, including the country, the currently considered as CCHF-free. So next, I want to talk about the backbone disease study. We have conducted the surveillance in the different areas in Zambia, but the major target of our study is filovirus disease. The filovirus include Marburg virus and Ebola virus, and both of them can cause the severe hemorrhagic fever for humans, like Marburg virus disease and Ebola virus disease. So ecology of filovirus is still unclear, but the ecology of Marburg virus is a little bit understood. So far, there is a report of the isolation of the Marburg virus from Uganda and DR Congo. And subsequently, many epidemiological data are accumulated, and currently Egyptian fruit bats are believed to be a natural reservoir of Marburg virus. However, major reports are made in Uganda and DR Congo. They are the endemic countries of Marburg virus disease. So the filovirus ecology outside endemic areas are largely unclear. So to understand the filovirus ecology outside endemic countries, we have conducted the bat study. So we have a cave near Lusaka, capital city, and this cave have a lot of the bat colonies. And at the night, they are coming out from the cave, and we capture them by using the half track. So we have collected the 290 serum samples from them, and then screened the filovirus antibodies by using the ELISA system. In summary, surprisingly, more than 43% of the bats had the specific antibodies against Marburg virus. Marburg virus. By sorting out the cell prevalence according to the sampling month, we found there is a biological November and December year. And next, we have screened the bats for the Marburg virus genome. And we found only 2 positive bats in September. So these data indicate in September they have active circulation of the virus among the colonies, and then they have a theoretical peak in November and December. Phylogenetic analysis indicates the Zambian strain is closely related to the Ugandan strain. It has a 99% homology in the 500 base pair sequence, which indicates Zambian strain also have a pathogenicity to humans. So not only filovirus and arbovirus, variety of viruses and bacteria from the bats in Gambia. I show the pathogenic microbes are colored in red, so which indicate that this cave provides suitable situations for spillover of the zoonotic pathogens from bats to humans. To better control the spillover events, the acting the bat is totally unclear. So now we are trying to understand the host ecology by, for example, foraging areas and long-distance migration behaviors. We are using the biologging technique. This is record and analyzing behavioral data obtained by data logger attached to animals like this. So by understanding the host ecology, we are trying to understand the virus ecology. So I'd like to introduce our recent activity in Zambia. So we have captured bats in the cave, and then we attach a data logger on the back of the bats like this. And then finally, we release them in the dark. And the GPS data can be retrieved by the antenna and the satellites. So this is a preliminary data. So this is the plan. And then here it's Zambia. The green line indicates the trajectory of the bat's movements. You can find a cave at the line here, and then you can find Tansiki Lusaka here. To better understand data of the bat movements, so each triangle indicates each bat tagged with logger. And this data is the every 5 minutes GPS position from the sunset and sunrise. So each bat are staying somewhere at night and then coming back into the cave. So they are eating fruits there. So after day 3, the green bats are flying very far across the capital city areas, and then coming back to the cave in the morning. Like that. The other bats are going to the south to eastern areas from the cave. So this is just a part of our data, but currently we understand from this data, there are some unknown caves in the eastern mountain areas here. And some individuals fly more than 100 kilometers per night. And then they sometimes across the capital Osaka cities, highly populated areas. And long-term tracking data indicates that there are the transboundary activities between Zambia and Zimbabwe. So by these activities are continuing, and then we try to understand the ecology of the bats. So finally, I'd like to introduce our established rapid diagnostic kit for Ebola virus disease. This kit is made under the collaboration with the pharmaceutical companies of Denka Seiken, and then the USAVET and INRB in DR Congo and us. So this device can diagnose the Ebola virus disease in 10 to 20 minutes, and the procedure is very simple and stable at room temperature at least a couple of years. We already donated these kits to DR Congo to control the Ebola virus outbreak in 2017 to 19. And actually, this Quicknavi Ebola has been already used in DR Congo to control the disease. And pharmaceuticals and medical devices agency in Japan approved this device in 2021 batch. So today, I do not have enough time to introduce our overall activities. We are not doing only virus research. We are doing the parasites and bacteria as well. By continuing this kind of collaboration with Zambia, we'd like to contribute for the public health of Zambia, not only Zambia, for the African continent. I'd like to show my appreciation for our collaborators. Thank you for your kind attention.
Thank you very much, Dr. Kajihara. Time so limited, I want to move to the next presenter because we may have questions after all the presentation. Thank you very much, Dr. Kajihara. Thank you very much. And next is Professor Suzuki from the Tokyo Medical Dental University, and he's going to talk about their research station in Ghana. Professor Suzuki, can you start?
Can you hear me?
Yes, pretty nice.
Okay. I'd like to share the slides.
Yes, we can see.
Is it okay?
But not presentation style.
Not presentation style. Okay. How about? How about this?
Oh, this is nice. Thank you very much.
Okay, thank you. Oh, habari za asubuhi. Is it okay? I'm very grateful for the opportunity to introduce our research project in Ghana. My name is Toshihiko Suzuki, project leader of collaborative research project between Noguchi Memorial Institute for Medical Research, University of Ghana, and Tokyo Medical and Dental University. For the past 40 years, Noguchi Institute has been conducting activities aimed at controlling the local infectious diseases through joint research with Japanese research institutes. Our collaborative research project with Noguchi Institute has been ongoing for 12 years, since 2008 with support of the Japanese government. Now we continue the research on several infectious diseases in Ghana, sponsored by Japan Agency for Medical Research and Development from 2020. This is current research organization chart. Each research item is in charge of the Noguchi Institute and Japanese researchers. I will briefly describe each research item. From left side, the project on malaria and vector mosquito. Professor Ishino of TMD, she is also attending this meeting, is supervising this project. By isolating the malaria vector mosquito genus Anopheles from endemic area in Ghana, we will analyze the interaction between the malaria parasites and microorganisms in midgut of mosquito. Second is viral infection, especially a study on dengue fever in Ghana. I will introduce the research contents from next slides. The group was also studying COVID-19 spreading in Ghana. And in viral diarrhea project, we are investigating the future of clinical isolated rotavirus from patients by long-term study post-rotavirus vaccine introduction. Next is antimicrobial resistance project of Ghana. I will introduce later in my presentation. We also study on Bluri-ulcer. This infectious disease is caused by Mycobacterium ulceras, and many clinical cases are reported mainly in West Africa, including Ghana and Cote d'Ivoire. Additionally, as collaborative research with other Japanese scientists, analysis of yellow fever virus, identification new malaria antigens, and analysis of mycobacteria using single-cell analysis technology are going on now. Today, among many research projects in Ghana, I will introduce the two topics in this session. The first is spreading, is dengue virus in Ghana, and second is the isolation and analysis of antimicrobial resistant bacteria in Ghana. Aedes aegypti, this is the vector mosquito of dengue virus, is widely distributed in many African countries. In West Africa, recently there are small outbreaks in Burkina Faso and Cote d'Ivoire, but no occurrence in Ghana. We wonder why no outbreak in Ghana. To investigate the actual infection rate of dengue virus in Ghana, we first collected the sera from patients with fever of unknown origin who are diagnosed to rule out malaria, and examine the dengue virus antibody titer in the serum of the patient. As you can see, this graph, antiviral antibodies were detected in about 60% of sera, suggesting the possibility that dengue virus may widely distribute in Ghana. So we think that future outbreaks can't be ruled out. We next tried to isolate the dengue virus from sera, and we could isolate two strains of serotype 2 viruses. The distribution of these viruses were estimated by analyzing the similarity of genome structure. As a result, the viruses are considered to be propagated from Burkina Faso, then causing endemic infection in Senegal, but no outbreak in Ghana in 2017 or 2018. These data suggested that some factors to suppress the outbreak of dengue fever in Ghana. In order to find out the reason, we focus the future of vector mosquito in Ghana. For isolation, Aedes aegypti colonies from urban, semi-urban, and two rural locations in Ghana were selected. The larvae were collected and grown to adult for oviposition, and collected eggs are transferred to Japan and established colonies for further experiments. 12 microsatellite loci of isolated mosquitoes were independently genotyped in each population by a discriminant analysis of principal components. 4 Ghanaian colonies, populations number 40 to 43, were clustered with typical mosquitoes of African origin. The mosquitoes were next examined their susceptibility to dengue viruses. This slide is one of our data. 1 colony from Vietnam as a control, and 4 colonies from Ghana were analyzed by infection with 2 dengue virus strains. One is serotype 1 isolated in Japan in 2016, and serotype 2 Ghana strain isolated by us. 7 and 40 days after feeding blood containing virus, the thorax and abdomen of mosquitoes were collected and analyzed the copy number of viral genomes. There are significant differences in the colony's susceptibility to virus infection. All examined Ghanaian mosquitoes were refractory to infection by serotype 2 virus. While some colonies are exhibited to the susceptibility to serotype 1 virus. Of course, further studies are necessary to discuss. For example, the serotype 1 virus is Japanese origin, not Ghanaian origin. How about the same serotype isolated from Ghana? To get answer, we now make efforts to isolate the other serotype dengue viruses in Ghana. Anyway, we concluded that the low susceptibility to virus Ghanaian mosquitoes is likely one reason where there is no outbreak in Ghana. Next topic is our study on characteristics of antimicrobial resistant bacteria isolated in Ghana. Drug-resistant bacteria are spreading all over the world, especially global spread of resistant bacteria against carbapenem as the last resort of antibacterial drug has become a major problem. Now, on the other hand, very little information on drug-resistant bacteria in Africa. So we started the screening of drug-resistant bacteria in Ghana using clinical isolates from the patients with infectious diseases. During our investigation, we found many drug-resistant strains. Some were carbapenem resistant, Escherichia coli or Acinetobacter baumannii. By further analysis, one of them was isolated as a New Delhi metalbeta-malactamase 1, NDM1 type carbapenemase producing E. coli. This is the first case of Ghana, and we reported in the scientific journal in 2018. We further analyzed the clinical isolates from patients from pediatric diarrhea. I will introduce one of our projects. Among 62 strains, 2 oxacilinase 181 type carbapenemase producing E. coli were isolated. So far, there are 2 reports describing the OXA 181 carbapenemase producing Klebsiella species in Ghana, but these OXA 181 producing E. coli were first isolation in Africa. The characteristics of E. coli were analyzed over whole genome analysis and genetic analysis of plasmid. Then we reported on emerging microbes and infection last year. This is the last slide. Dr. Hideo Noguchi, the famous Japanese microbiologist about 100 years ago, died of yellow fever in 1928 in Ghana. In commemoration of Dr. Noguchi's achievements, the Japanese government constructed the Noguchi Institute in 1979 as a symbolic research facility for medical support of Africa. By continuing collaboration studies with the scientists of Noguchi Institutes, we hope we can contribute to the prevention of infectious diseases and public health in West African countries as well as Ghana. That is all my presentation. Thank you for attending. Thank you.
Thank you very much, Professor Suzuki. Okay, so time is so limited. I want to move to the next presenter. Next presenter is me. So I'm going to
introduce Professor Kaneko.
Oh, thank you very much. You introduced me.
Next speaker is Professor Kaneko from Nagasaki University. The presentation title is Introduction to Nagasaki University Institute of Tropical Medicine and the Chemistry Project for Tropical Medicine and Public Health Research. So please start.
Okay, thank you very much, Dr. Kido. So I'm going to present our research station in Nairobi. So I'm Satoshi Kaneko from Nagasaki University. Actually, I'm a representative of Nairobi Research Station. Okay, so this is some kind of history of our research station. We sent a medical team to Kenya in 1966. For 10 years, they worked for Kenyan people to treat any diseases. After that, we joined JICA Technical Cooperation Project to establish KEMRI, Kenya Medical Research Institute. And after that, in 2005, we established the Kenya Research Station. Then we actually start research and training from this time. And for the first time, we built some small facility like this, but after that we put something like this, and we also have a research station in the field in Lake Victoria side and the Kuale side. Kuale is kind of a coast area. And we have a P3 laboratories and HDSS, I just for health and demographic surveillance system to work for epidemiological studies, and the mosquito surveillance program and training facility for laboratory training. And 2021, just last year, we have some fund from the Japanese government to respond to the pandemic of COVID-19, and we do something in our research station in Nairobi. So what we do is, I want to explain a little bit. So we set up several equipment, and we renovated our laboratory like this. So currently, by the funding of Japanese government, we have a gene analysis laboratory like this, and also molecular laboratory we set up like this, and also P2 laboratory for parasitology and protozoology like this, and also we have open laboratory because sometimes we have a researcher from the outside of Nagasaki and the Kenya Research Station and our Cambridge project. And also we have P2 laboratory for microbiology and the P2 laboratory for biology. And also freezer rooms are available like this, and we how many freezers? Lots of freezers, 1, 2, 3, 4, 5, 6, 7, 9 freezers we have to keep samples. And also cell culture room we established like this. And also we set up a DNA extraction laboratory room like this for entomology and parasitology. And also we have a gene analysis laboratory. We set up a next generation sequencing machine like this. And also electrophoresis laboratory we set up. So this kind of facility we set in Nairobi, but in Kisumu, near your station, hotel. And we set up a laboratory in Kisian, Kemri, like this. So this is for entomology team. So they are using for a mosquito analysis, like this. And so they set up some facility like this in Kisian, Kisumu. And also our Nagasaki University Institute of Tropical Medicine is designated a joint usage and research center. That's why our facility can be used for researchers who want to use our laboratory in Nairobi. So that's why I'm going to invite some of you to come join and research together. And also I want to introduce some activities in Kenya by Nagasaki University. So we have several teams. So first was a biology team by Professor Inoue. And they are doing some research in tick-borne disease viruses like this. They are getting some far samples and they do analysis using our facilities. And also mosquito-borne virus disease research is doing like this. So they're collecting the viruses and they do analysis. And also we are also doing some technical support for Kemri and Kenyan government of COVID-19 diagnosis like this. the first time, so we provide our facilities to give some diagnosis for COVID-19. And we have another team, a parasitology team led by Professor Hamano. This is mainly schistosomiasis leishmaniasis. So we have some a station, field station, Lake Victoria side, and this is the Indian Ocean side. And they have some project with both sides. And using the GHIT fund, this is a kind of governmental neglected and HIV. Professor Hamano got some grant and he's doing research for vaccination development for leishmaniasis and also some development of diagnosis of leishmaniasis and schistosomiasis. We are doing such kind of research in Kenya. And also Professor Hamano got a satellite research for science and technology research for development. Accepted this year with the government of this project. Maybe next year we can start. This is the research and development towards control and elimination of myiasis. We are working together with Shimazu company. This is a kind of some measurement of the DNA, maybe from the environmental situation. And we have several universities join. Maybe this is a 5 years project. I hope we can do some research using this one. Okay, so next one is the entomology team. Professor Minakawa and Dr. Stami doing. We are doing some research about vector mosquitoes using our field. Maybe they are evaluating and doing some research for this. Doing some trial with about definite effectivity. And also they are doing the field research Aedes mosquitoes, not only in Kenya, they are doing other African countries. So they are collecting mosquitoes in several places and also we also have epidemiology team led by me. And as I mentioned, currently we are using several mobile, some servers, and some systems that we registered people in the field. I think we are registered we are changing some system, this one. So we registered more than 60,000 for. Additionally, this is the kind of data we are doing something. This system we are doing some epidemiological studies, and also we are now developing human and newborn babies because of, this is the kind of even this one also using the computer system, cloud system. Based on the clinic, we record information from the mother and child health booklet. Then we register mother and infant both, and we are following up. And based on this system, we are doing some research. We named the birth cohort. So because we can capture all the babies born in this area, so we are now following up and doing some research. Especially, we are focusing on effect on the growth of the babies. And they are focusing on the elder persons in community. They are doing some research for the person in the community and how the response that are doing in the communities, something like this. Maybe we may have a nice data from here. And also we have a JICA Tuniasis grassroots project in Homa Bay County in Kenya, like this. So we have a research station in Itahia. So their field is larger than this one. Maybe they are doing some area like this. So this project is not research-based. Normally, the community-based implementation for control of gases. And this is the objective. This is to reduce the mobility of gas in the project area. And for that purpose, they are doing some surveillance now, and also capacity building, and also health promotion. We are change for the community people, especially for community health volunteers. And also, we have several projects with companies from Japan. As I mentioned, Symposium Chemical, we're doing some research for BetNet, and the sequence companies for the environmental DNA measurement. And also, we are doing research C company. This is for biometrics to identify the people. For example, we identify babies to follow up the babies for a long time. We are doing some research like this. And the Malaria company, we are doing psoriasis clinical trial from now. And also Aiken company, this is the LAMP method developed company. We are doing this TB diagnostic LAMP method evaluation in Mombasa. And also we are doing some human resource development issues. We have an inter-university exchange project supported by Japanese Ministry of Education. This project is kind of they are supporting the exchange of the students of several countries between Japan. I think that's all. So to save the time, so I run shortly. Thank you very much. I think that's all.
Thank you very much, Professor Kanikawa. So, the unique energy metabolism that comes from the parasites the parasites almost depending on the glycolysis for ATP producing. To maintain this ATP, the glycolysis, the parasites maintain this glycolysis to keep the terminal oxidase, named the alternative oxidase, which is completely different from our respiration. Our mammalian using the cytochrome C oxidase. The cytochrome C oxidase is inhibited by cyanide, but the oxidase of the parasite is not inhibited by cyanide. So we mentioned that the cyanide registration respiration in the parasite. This is our drug target. So we have identified one compound named ascofuranone inhibits this terminal oxidase at a lower concentration. So we have analyzed the partial structure of this drug target and combined with the drug. So by doing this, we have really modified the chemical structure of the compounds. Now also, we have conducted the structure-activity relationship by chemically synthesizing the derivatives. So eventually, we have found the optimized derivatives, not the real compounds. This is the chemical structure of the optimized one. So this is the result of the original lead compound. This is the model of the acute infection model, which is conducted in Japan by oral monotherapy. The original compound cannot cure the infected mice. Unfortunately, compared to the control one, the blue one, the administration of this drug would favor, but all the infected mice will die. But in optimized compound, by even oral monotherapy can cure the infected mice. So we have moved on a chronic infection model. It can be conducted in Africa. So in our collaboration, so we have dispatched our young research and graduate students to conduct these animal experiments. So we have established the chronic infection model by using the clinical isolated strain, not the experimental strain. So the previous slides, I introduced the acute infection model. In the acute infection model, the plastemia is increasing very simply, but in a human, the parasite is very complex, is waving like this. So by using the clinical isolated strain, so in the DRC, we take up the chronic infection mice model. So in the mice, the parasite is waving like this. And using this infected mice, we have
and sorry for rushing you. And I will give it back to Professor Oguma. It's okay?
Yeah, sure. Thank you so much for leading the session, Professor Kaneko, and Professor Kido. Is Dr. Suzanne Nillen still there?
I'm here.
Yeah, just a quick one, because you realize that you are the only speaker in this session who has something different from the rest of the speakers. The rest of the speakers have Japanese-funded projects in different countries. Having listened to them, I was wondering if you have any comment on question, on clarity, given that you are from a different country and they're presenting from maybe the same funded projects.
Sorry, I didn't quite follow.
Oh, yeah. Can you hear me very well?
I can hear you, yes.
Yes, I'm saying that you realize that you are a keynote speaker in this session, but you are from Karolinska Institute in Sweden, and then the rest of the presenters had Japanese-funded projects in different countries. So I was wondering if you noticed something that you wanted to ask a question on, or for clarity, or...
No, it was very interesting to hear about all the ongoing work, and as I have worked on leishmaniasis quite a bit in India, it's really nice to hear about the vector transmission studies ongoing, and the data. I had a question about sort of development of leishmaniasis in Kenya, because it's been declining for quite some time, the situation, how it is.
All right.
Yes, that's why, so maybe this is a good opportunity to link the researchers. Maybe if Susan is interested in leishmaniasis, we can link the Professor Hamada. He's doing some research in leishmaniasis and vaccine development also.
Sure.
Yeah. Thank you.
I think that will create a good opportunity for the different institutions to link up on the same area and try to have some commonality in research, and probably also link some Kenyan institutions in that area. So it was nice listening to all the presenters, and thank you so much for this morning sessions. Let's give an applause to the team presenters and for us. I know Professor Miriam Were was not here yesterday. Maybe you can just stand up and wave. You know, people don't know you. Me, I know you. But we acknowledge your presence. Professor Miriam Were has been an established professor in HIV research, and she's here she'll be giving a presentation much later, and she'll be introduced properly, but we acknowledge your presence, Professor, and we feel welcome. Yeah, so with that, I think we qualify for a tea break. We'll have to let us try to have 25 minutes tea break. I think it's still the same point. Second floor, you have a question?
Yes.
Can you pass the mic? As the mic is getting passed to her, to him, sorry, we will have the tea break on the second floor where we were yesterday, but you can go ahead.
Thank you very much, Honorable Chair, and I would like to appreciate the presenters for the wonderful presentations and for sharing the progress on what's going on in different areas, especially on the NTDs. Michael Katende from the East African Community Secretariat, Health Department, and I'm sure you just imagine what my interest would be here. As a region, we are integrated. We are moving closer to being one, actually not moving closer. We are already one body. And with the free movement of persons in the region, I would imagine that the work that has been done in different, mainly in Kenya, would benefit the region. And I would like to appeal to our presenters and maybe those who are here to try and link with the Secretariat to come up with a harmonized approach on tackling NTDs. I can imagine that different countries have a lot going on in their countries, but the ability to share this information, inform policy, and inform programming would give us the impetus to move forward. So my request here is to try, I'm requesting that we use this opportunity to engage with the regional body to come up with a harmonized approach and a strategy that all of us fit into and we guide our efforts. So this will be my request, and I know the professors who are presented will be very happy to work with us to support our region as we continue with the research, but also the policy angle is very important. Thank you very much.
Actually, the NTD is a neglected tropical disease. They're still neglected. And that's why I think the point you are raising is quite important, so that they're able to share information so that people can come up with a framework for dealing with those particular diseases. So I fully agree with that, and I think the Secretariat have not taken note of that, and will make a follow-up on that particular element. If there's nothing burning, I think we'll get a 25 minutes break. It's 10:50 according to my watch, plus or minus 2. So we can be back by 11:15. We want to try to finish much earlier today, so that other people who have to travel. So let's try to keep to the time. Let's try our best. Thank you so much, and enjoy your tea break. Thank you.
Hi, Shugishita, can you hear me? Ross?
Very well. Mara. So, Mama, floor is yours.
Thank you very much. It's a great joy to see this gathering. Focused on one of the problems that we have. Also, in my life, I have had problems about malaria. And I'm hoping that it will soon come to an end. As I was reading on literature on malaria, papers written in 2015 were saying this was a global problem of serious consequences for global health. But the papers that I read 2022, even one in June 2022, says this is now predominant. It's no longer a global problem. It's predominantly a problem of sub-Saharan Africa. I said, hey, why have we been when everybody else was reducing malaria? I said, it's bad. We have not yet. Yeah. So I was quite concerned. It may be partly because of my age, because I was hoping that by the time I go from this world, I'll be no malaria. I believe that it's still possible, but I know to work. So in 2018, people were saying that it was a global serious problem. But by 2022, the report is saying it is now not a global problem, but a concern of Sub-Saharan Africa. And why? Is it just because we like malaria? There are some reasons why malaria likes Sub-Saharan Africa. That First one reason is that we have a lot of rain, and malaria likes water. Another reason is that we have high temperatures throughout the year, and the malaria likes to be warm, it doesn't want to be cold. Another problem is that malaria likes, the malaria prevention system likes high temperature, and we have that. And malaria to survive needs stagnant water for the live to mature and grow. And they find that. So all these conditions are found in sub-Saharan Africa. Sometimes in my discussion with scientists, they say they don't like this simple problem. These are not scientific problems. These are general problems. And the ones simple scientific stuff, I always wonder what they mean. What would be more scientific than the desire to survive and for your people to survive? So I hope that we can inspire the modern and future generation of scientists to be concerned about issues like stagnant water. Stagnant water. Maybe it's not scientific to claim stagnant water, but it is human surviving time. So that's one of the first point I would like to make, is that as we look at the challenge of malaria in Africa, we should get out of the recipe of hard science. I have never known when people mean differences between hard science and ordinary science and what more and what more. So if malaria used to be a global problem and it's not now at all, what have other people done to reduce it? Because we need to follow the same path for Africa, especially for Sub-Saharan Africa. What are the insecticides that they use to kill mosquitoes that spread malaria? Are they available to us? Or do we have money to buy them? This issue of money and finances for African health is a very serious one. So we need to have very serious discussions with our political and financial leaders on the issue of malaria control. The other things like grading stagnant pools, it really doesn't require much other than human effort. How are we scientists involved in mobilizing people for the common good? Because on scientific things that we despise because they are not hard science, like drinking water, how are we going to be involved in those things? And how are we going to be involved in helping Sub-Saharan Africa to survive, or at least to be in good health? I don't know how many of us visit the villages regularly. I say the villages because if you just stay in the city, most people in the city can afford medicine. So even if they get sick, they can get medicine, and unless you go to the slums of the cities, which I sometimes do, you don't really see sick people. So you can live under the illusion that we are living in a very healthy place. But in fact, I would like to encourage all of us, especially the scientists, to visit the communities at least twice or 3 times a year, so that reality can hit you. Because it often hits me. I go to the village even at least 6 times in a year, and it's never away from me that people in the villages are suffering and dying from conditions of malaria. So if people have controlled malaria through insecticides, what is it that keeps us from using the same method to control it? Is it the money, or the lack of interest, or the lack of provision of the funding by the treasury? We can't just sitting up there as scientists and are involved in how to get the solutions. So when I speak, I know that there are going to be a lot of lot of hard science being presented. That's not my role. You are doing the research and you do the hard science information. Mine is how are these things benefiting us, benefiting the people? What are the obstacles without using mosquito insecticides, treated nets? How are we involved in that in our communities? I was involved in a program at one point where we had an organization which had offered free insecticides nets, which were even treated. But you know, there were no takers. Even in the most malaria area, people didn't come up to take them up. And I must say, some of those areas where people did not come to take them up are some of the areas where we have lost some of the biggest scientists in the health sector. And I was asking them, why are you making the people aware that this is life-saving? But I think for some of us, what we do about taking an insecticide is not hard science. So I really want to appeal to us to stop putting separation between health science and soft science and non-scientific. And consider, is this life-saving? That's the question that should be determined in our mind. Is this actually life-saving? But that is hard science, who cares? What is important is this life-saving. So we used to have these insecticides, and people didn't take them up. I bring a report and I want to tell people take insecticides. They say, hey, what has she put in the insecticides that she wants us to take? They somehow feel suspicious about it. When the local scientists are not promoting it. So to what extent are we participating in the perpetration of malaria as a problem because we are failing to communicate relevant information with the people? You will probably get that in my feelings of teaching on the issue of communication with the people. Because I don't just like to be fascinated by knowledge. Knowledge has fascinated me, but the question always comes up, so what? Knowledge in my head and people are dying around me, it's not very fascinating. So what? So, using insecticide, using repellent, what is keeping us from using it? Using medicines that cure malaria, that prevent malaria. Is it the money? I was looking for specific information, write-ups by modern scientists themselves, to say the bottlenecks to malaria control are the following, but I didn't find it. Are you doing research on the bottlenecks? I haven't done research for some years. But I think we need to do research on what are the bottlenecks in the chain to the eradication or elimination. Because what has been done in other countries is what we need to do. That makes it easier for us because we have a practice on. We don't have to be very original in thinking of what should we be doing. We just need to apply what others have done. If we don't succeed in controlling or moving towards the elimination of malaria, what is the alternative? What is the alternative for us? Our children and our grandchildren. I have known people who are scientists, but there are no members of their families who are scientists. And most parents don't train their children who are not in the scientific area to become scientists. And so you find that their grandchildren are in the same problems like everybody else. So the safety that many professionals and scientists feel, the concept that I know there will not be hurt is actually short-sighted. Because your grandchildren may not know. And therefore they will die from malaria and other things like that. So we need to really be concerned about humanity beyond ourselves. So what are some of the ways that I think we should really, the professionals that know the facts, we need to do? I think the first one is that we must communicate effectively with our political leaders and other social leaders. The problems out there always seem very, very serious problems, but we must make them realize that the problem right here are very serious. I remember when I was pushing for the control of diarrhea because I was tired of going to World Health conferences and meetings where diarrhea is no longer a killing problem, but in Africa it's still #1 killer. And I was tired of this. So I began to go to head of state to tell them, do you know that diarrhea is killing your children? As much when I said that I want to come and I would make an appointment to speak to the head of state of Uganda or Tanzania or Kenya, East Africa especially. We want to talk about that out of diarrhea. You want to talk to the head of state about diarrhea? Yes. So afterwards I stopped talking about the topic. I guess I want to talk to them about serious health issues. And when I got there, I talk about diarrhea. And I have all the details on my write-up, and I say, for the president of Tanzania, this is what malaria is doing to your country. This is what it's doing to your citizens. And all of a sudden, they pay attention. All of a sudden, they make sense. And you go to Uganda and you do the same, you go to Kenya and you do the same. So I even lived in South Africa. This is what malaria is doing, and this is what diarrhea is doing. And people became very serious. The leaders became serious. They came to ask their ministers of health, what are you doing about diarrhea? And the ministers of health began to ask their officers. And diarrhea as a disease, as a care disease, began to go down. Because at something like diarrhea, nobody can really stop it from you. It is a matter of hygiene, food hygiene, and so on, which indeed your families must do. And malaria is also very close to that. Draining the stagnant waters, making sure that if necessary we use insecticides, making sure that we use lakes. These are also not hard science issues. They are people-related issues. So I want to challenge us hard scientists. What is the level of your involvement in ensuring that the hard science in your head is reaching the people? Because so long as it is in your head, it is of no value. And since all of us die, it will die with you so much. Who will remember that, oh, maybe I'm going to die with this in my head. That's useless. So what extent can we leave the knowledge in our head with our people, making their lives better? So we need to communicate very effectively with our political leaders. And if they don't want to hear, you still have to talk to them. It's not an option. Malaria is killing Africans. Or it has stopped killing people all over the world. When I was reading on this topic, it says, there are so many deaths, there are so many cases per year, there are so many deaths per year, and these are mainly from Sub-Saharan Africa. It's happening nowhere else except in the West. That's what we must ask ourselves, why us? So please let us act as the people who know. For instance, not only to Almighty God in my opinion, some of us want to get the information when others don't know. So we have a responsibility as those who know. How are we transmitting this information to the people that we need to get in their lives? One of the things that I have found scientists very disinterested in is the idea of community participation. Bringing people together in groups to discuss and learn how they can place as the method of communication with the people. How do we do it? Do we do it directly ourselves? Do we do it through other people? Do we do it through what modalities are we doing it? And I'm telling you, mostly the scientists from Africa, although how are we organizing groups to discuss issues that are still affecting our health? An issue like malaria, which is no longer an issue anywhere else except for us. So, community action against malaria. How many of us have organized, have helped to organize, or encouraged to organize community action against malaria? I used to organize community action against childhood death, against early childhood death, and so on. So that's part of my background. And it was amazing. I felt very bad that I hadn't done it. It was amazing how much people effective change for the person. Because they always thought it was something mysterious. But when you bring it down to earth and help them understand it, they realize, oh, it is in our hands. At this whole business of going, encouraging mothers who are pregnant to say that the liver has started, because in many of our cultures, people don't talk about liver, that my liver has started. So people get to know about it only when the child is about to come out. And the woman has never been pregnant, so we don't know whether her passage is big enough for the baby or not. And so we don't know if the baby is too big for her passage. We don't know. And then she comes to you when she's in labor. Many times in our communities, we don't have the facility, the transport capacity to organize transport from that and take her to hospital. But once people understood this, then they would know that I'm in my last month of pregnancy. So I must go, they must assess me to see the size of the baby and the passage. Are they okay? And then within a matter of 2-3 years, childbirth death ceased in many of the areas where we work, and then people knew that, oh, it's no longer a problem that is in the hand of God. Because that's what we always say when people die. It's in the hand of God. No, it's not in the hand of God. Most of the time it is in our hands. And so, to what extent are we organized community action for them to understand and to be able to take action? And then, what will happen if we are not effective in controlling malaria? Are you going to live all your life watching people die from malaria and die and live and die from malaria? I hope you don't get comfortable with that. What would you say if you stopped from killing people in your generation? As someone who grew up in Africa, you are used to thinking in terms of what have I stopped in my life? What will you have stopped in your life? Can you set up the challenge of stopping malaria from taking place in your area, in your country, in your world, in your nation, in the continent? Because I have found that it is only when we take personal responsibility to end a problem that we actually have problem comes to an end. But if you say, but you know, it is up to the politicians, and it's up to who, and it's up to who, when you just find that they are going around in circles. Malaria is a complicated problem, as you know, in terms of scientific information, which I have not tried to catch because you know it's preliminary. But the actual approach that we are dealing with are this kind of thing. I think this is what are you going to do? Please give more information. And also affects their economic capability. And in many of our countries, malaria keeps people sick 160 days by year. If you are sick for 160 days, how many days do you have to look after your land and become productive economically? So these are realities. They are not theories. They are realities. And I know that we have the capacity to stop this level of morbidity and mortality. Therefore, I encourage you and I pray for you to succeed in your generation in putting an end to malaria as a killer disease, as a morbidity overriding problem for Sub-Saharan Africa. Thank you very much.
Thank you very much, Professor Malaria, for your inspiring speech. And echoing to that passionate speech, we have 4 presentations from Kenya and Japan. First speaker is Professor Margaret Kasaje, Tropical Institute of Community Health and Development, and also my mentor. She's going to talk about malaria and development, community perspective. So, Margaret, yeah, floor is yours.
Thank you very much, Sugi. I'm not sure who is the mentor, whether you are the mentor or I am the mentor. Thank you very much. Thank you very much, Professor Miriam. I remember when I was a student at Johns Hopkins, where she did her DRPH. I got a job in the library as a student at the Johns Hopkins library. And in between giving books to the students, I would look at her write-up, her PhD write-up. And what fascinated me was the way she described community engagement. How do you get the community to be engaged? What is it that they can do? What is the partnership? And that's what I'm going to talk about. What is the role of the community? What is the community perspective, especially for malaria? Malaria kills. I lost a brother who was 8 months old in the 1960s because he had malaria. And it happened in the village. And apart from drinking the bitter aloe vera, there was no other treatment that we knew. And to get the quinine, one had to travel long distances. And my mother never managed to get him to the facility in time. So malaria kills. Yes. Okay, it's on the screen. So I will just look at the community perspective. Sorry. We've talked about this, about the malaria burden in the African continent, and thank you, Professor Miriam, for just emphasizing that it's no longer a global problem. It means that it is our problem. So if it is our problem, what are we doing about it? Malaria is resurging, and from yesterday's presentations, we saw that in certain parts of the continent, malaria is now coming up again. And somebody mentioned yesterday that now malaria is being seen more in the older children. It's now left the under 5s and it's moving up to the older children. What are we doing about that? And because our health systems are so complicated, it's not just the issue of funding, it's the issue of human resources. What are we doing? Who can we harness? Who can come together so that we can look at new ways of just addressing malaria? I appreciate the science that is going on the science that is helping us to push the frontier of tackling malaria. And I'm going to make a point that science is needed, but the so-called non-science, the softer side of malaria intervention is also needed. And they all need to come to the table to make a difference. We know that early detection and treatment can save lives. And there's an example. For instance, I have 2 PhD students who are looking at malaria, they're looking at COVID, they're looking at Ebola. One student has demonstrated that there is a close link between a community intervention and survival in Ebola. And what is the link? It's that community aspect. Community volunteers being able to detect a potential patient of Ebola, linking that person to a health facility, and then the intervention is taken up. And interestingly enough, there is also some link between the diet of Ebola survivors. And the diet is the diet that has been recommended by community household visitors, the volunteers, saying you should eat more of this type of food against this other type of food. And there seems to be a link. There's more research that needs to be done, especially on selenium. Selenium and the link between Ebola survival. There needs to be more research on that, but there seems to be a link. And the link here is not just a scientific chemical link, but the role of the community volunteer who visits the patient, who encourages them to eat, and to maintain their health even as they fight the disease. In Siaya here in Kenya, we were part of a study of COVID-19 way early in 2020. When COVID was ravaging the whole globe, we very quickly got the community volunteers to come together. And it was simple. The usual preventive practices that they know: cleanliness, wash your hands, distance, keep the patient isolated, wear a mask, prevent any nearness to the patient. Because these volunteers had gone through maybe not a similar epidemic, but they'd gone through cholera. And in this region, when cholera happened in the 1990s, the community volunteers were very, very strategic in making sure that households were boiling their water, they were drinking boiled water, they were isolating the patients, they were cleaning utensils, and so on. So my point is, we do have the human resource, especially at the community level, and we should not forget them even as we look at the hard science. In Siaya, for instance, it has been demonstrated that during the COVID period, essential services were going on, and community volunteers were encouraging mothers to go to the facility despite the fear of infection of COVID. Mothers were still going for their routine visits, and people were still making access to the health facilities, and this is because of the encouragement of the community volunteers. I really appreciate the way that it has been demonstrated that communities are taking part in research. And in Siaya, we can see, because of the community health worker intervention, as we speak, Siaya County is number 3 in vaccine uptake for COVID-19. Now, vaccine access, vaccine uptake has been a problem globally, because there are all kinds of rumors, there are all kinds of hesitancies in taking a vaccine which they feel has been too rapidly developed as compared to previous vaccines. So here we are talking about the role of the community. It needs to be brought to the fore, to the upfront. And then when we look at the common interventions that one has in preventing malaria, we are told it's no longer malaria control, but it's elimination of malaria. Can we have the next slide, please? When we look at the interventions of malaria, those are common interventions that communities can do very effectively. For instance, use of nets. It's at the household level. And who is at the household? It's a community member. Where does malaria start? It doesn't start in the laboratory. It starts in the household, at the household level. If you're talking of spraying, it's at the household level. If you are talking of repellents, if you are talking of diagnosis, who would first know that somebody is likely to have malaria because of the fever, because of loss of appetite and so on? It's the person in the household. If it's about pregnancy, encouraging the woman to go to the health facility for IPT, it is the community member. Where it has emphasized is, do we really know why some of these interventions are not taken up? If it is nets, why is it that households are not using nets? If it is effective, and it has been proven to be effective, if it is sprays, what is it that is preventing the uptake of the action? And maybe we need also to look at the side of socio-cultural, socio-economic issues that prevent us from really having an impact on malaria. Because sometimes the knowledge is there, but there are certain other hidden challenges to the household. And somebody yesterday said that malaria follows poverty, or poverty follows malaria. Those two are interlinked. What is it that is preventing a household from using nets? What is it that is preventing a woman from going to the facility to get malaria prophylaxis? What are the hidden information that we have? So I think we need to also have a very serious laboratory engagement, and it needs to be engagement, and it needs to be real community engagement. We need to have a plan interaction where we talk to members, different members of the community. And it needs to be not just both stakeholders. Go to a facility without consulting my mother-in-law. What about the males? So often we have focused in our interventions, in our public health interventions, we have focused on women and children, and we have forgotten the role of the man. And yet that is so critical in some of these actions that are needed if we are going to eliminate malaria, as an example. We know that malaria now is occurring in specific pockets, even in the continent. And I know WHO keeps on reminding us that we don't have enough human resources. And in Africa, some of our people are going across the seas and are now populating other health systems, and we are left with inadequate health resources. How about looking back? Community engagement. And then I propose that in terms of the community engagement, each person, each group, each entity, this is a diagram that I want us to just look at very quickly. The frontline providers, and there we have consumers who are the communities. And I'm proposing that this is a critical area in this strategy of malaria elimination. Let's put a bit more effort into the community, because as we engage them, then we are going to see new steps. Because at the end of the day, it comes back to them. Are they going to use the medicine? Are they going to use the intervention? And we need to give them a greater role in planning for malaria elimination. Thank you. So as the saying goes, if we put all our webs together and unite the pure scientists, the social scientists, the communities, then we can tie up the line. Thank you very much.
Thank you very much, Professor Erokampanaya. So, Margaret, thank you very much for your inspiring talk, and the passion always goes to community. And the community engagement task force is a quite good idea, especially in the Lake region. So, second presentation, we will welcome Dr. Amit Thakur, Executive Chairman, Africa Health Business. And Amit, you're going to talk about malaria and development, business sector perspective. I think, yes, Amit, yeah, floor is yours.
Thank you. Thank you. I hope you can hear it. Can you hear me?
I think your voice is echoing.
Yeah, Professor, I just want to confirm everything is okay on the sound
It's
side.
okay. Okay now. Sound is okay now.
And could you also check if the slides are going to be shared by the host or I can share them myself?
I think you can share your slide by yourself.
Okay. Let me first get hold of them because I would like to thank everyone who has put this Malaria Symposium together. I would like to thank Professor for this long-standing engagement that we've been having. I also would like to thank all the organizers for putting this important session together on malaria. As mentioned, I will speak a little bit about the private sector perspective on malaria. I want to send my greetings to the previous speakers and also to the keynote speaker, Professor Miriam Were, who gave a very inspiring talk today. What I've been asked to share is where does the private sector fit into malaria? With the screen that you can see, I'm going to talk a little bit about business perspective. And I am the chair at the Africa Health Business. I'm also the president at Africa Healthcare Federation. And I want to talk to you about the kind of work that we do in Africa Health Business for malaria. We basically create partnerships in the countries that you see on your screen below. This is where we have all our partnerships across the blue countries, and we have developed some very strong partnerships with the private sector and the public sector, and we work closely with the Ministry of Health to ensure that the health systems in Africa remain strong. Malaria is a very interesting conversation in the private sector because it provides an opportunity and it also provides a way to improve health and overall well-being because of the burden it has on the community. I also believe that with many subsidy programs, donor programs and government programs, private sector finds itself in a space which is not well attended to or sometimes needs stronger support, especially in treatment, diagnosis and therapeutics. Those are the key areas. I will talk to you a little bit about the vaccines and what the private sector feels about that for now. So if you look at how we challenge health system problems across Africa, at Africa Health Business we have 32 strategies and approaches, as you can see. We have 8 solutions. And for malaria, with our clients and organizations, we have seen a lot around service delivery, as I mentioned earlier. There is a challenge around financing in most countries in malaria because many people still have to pay out of pocket. Either it's affecting a child or another family member, and if the insurance or the UHC levels are low, you find it that many people have to still pay out of pocket. So like many countries, like in Kenya, the idea is to have a wider NHIF coverage, wider insurance coverage, wider community coverage, so that we don't have challenges when many of these patients are seeking care. So financing and delivery are the 2 very important subjects currently for malaria in the private sector. There is another area that the private sector is doing very well and is supporting the systems across countries. It's called products and supply chains. And in this place we have pharmacies, we have wholesalers, we have distributors, we have importers, and we also have manufacturers. The manufacturers in most of Africa have been finding a small challenge, especially when the Advent subsidies started getting introduced. So the mechanisms ensure there is some standard quality purchasing and supply. So the market, a little bit of the management of malaria, and then I will talk about, but it's clear that it has a big impact on economic growth and development for Africa. I was actually looking up and seeing that Africa does host 95% of the malaria cases, and this in itself is a big burden, and it's about time to look at innovations that will try and reduce the malaria cases. But innovation is not enough. I think investments also have to be aligned. Without getting the right investments from the public and the domestic sector and the development partners, we might find ourselves in a very tricky situation to eliminate malaria. About 80% of the deaths are among children. We've heard it's affecting older children as well. But this future generation that are the hope for the continent would benefit from the leaders gathered today online and across the world and in Kenya to align the action that will ensure the future of Africa, which is a youthful and a very dynamic population, to not get affected by this condition through our action programs. We know that the vector control, therapies and vaccines are the center line of discussions when it comes to the private sector. I will discuss a little bit about chemotherapies, vaccines and vector control in this business case for malaria that you see on your screen now. The business sector perspective is pretty clear because there are 4 key areas that we are all looking at. One is innovation and research, diagnostic treatments, investments and partnership. As I mentioned, vector control needs to be guided by the science and epidemiological and entomological data, insecticide resistance and vector behavior. Countries should also collect data so we have an evidence-based action plan. The innovation and research also lends a very great opportunity for private sector where we have been opening several research innovation hubs that will look at how to tackle this condition. You have all seen that over 600 health tech hubs have been opened in the last 5 years. The 4 countries where there is an intense activities, Nigeria, Egypt, Kenya and South Africa. Over 3,500 new companies were instituted in the last 2 years in these tech hubs. After the pandemic, it's become clear that innovation is non-negotiable and it can only work through collaboration. So that's one big area that I did want to mention to the team, that investments and ideas about partnership will be happening under innovation and research. Under diagnostics and treatment, I am glad to report that several companies are looking at making the diagnosis of malaria much easier, from the elaborate staining mechanisms in the lab to very easy point-of-care diagnostic systems that will have accurate and timely diagnostics of malaria. Recently, we've seen innovations also around curative and new molecules and treatments. But most importantly, I think the excitement about vaccines is coming in pretty rapidly. With COVID-19, it was clear that we have a goal that we should be producing 60% of the vaccines in Africa by the year 2050. At the moment, our vaccine production is 1% of what we consume in Africa, manufactured in Africa. We realized that when we do the vaccine investments, it is beyond COVID. It will include other ailments, and malaria should be one of those. When we look at investments, there are several investments required across the whole spectrum of malaria control. There are several programs at the moment dependent on donor funding. So moving from donorship to ownership is going to be a right strategy in order for the African health systems to be self-sufficient. Over-reliance on donorship gives us that weakness and that disconnection from self-sufficiency. This leads to action-oriented, respectful partnerships. And through that, we will have the new age Africa. A new public health order has been spelled out for all of us, for the continent. Led by the Africa CDC, the 5 pillars are wonderfully structured that will address challenges of both communicable diseases and non-communicable diseases. We have adopted the new public health order as private sector entities within the healthcare space, both globally and in Africa. I'm happy to report that in December 13th to 15th, we will be at the Public Health International Conference in Kigali. It's not just an event, it's an amazing time that most leaders in public health will get together. And in April next year, we will be launching the action-oriented respectful partnerships where private sector will become a key pillar in investments in NCDs and CDs, including malaria, so that we attain our goals. This is going to lead to the conclusion of my presentation, where I mentioned both international and domestic contributions need to increase sustainably above the current spending. We are spending some few dollars in malaria, but we need to do more. There's absolutely no doubt that we need more funding in order to look after the future generation that are being unfairly hit by this burden of malaria, reducing life expectancy of the hopes of many children. These are the amounts that we need to look at. We need to go for a 6.4 billion by 2020 to meet the first milestone of 40%. We fell short of this, so we need to pick it up. And the pandemic did not help us. Lots of funding and healthcare was diverted into the COVID-19 pandemic that reversed some of the gains that we were beginning to see in malaria. Then you can see, as you scale up for every $1 billion, the amount of reduction on malaria are seen and estimated there. The cost of implementation has been estimated from the quantities of goods required for expanding intervention, multiplied by the estimated costs of the provider of delivering each intervention. And you can see, I'm sure you read this data and statistics on the WHO annual malaria reports. So, in conclusion, Professor Shugishita, we will need more funding, we will need more partnership, and we will need collaboration with the nation to make sure we deal with this malaria pandemic, or with malaria burden fairly and squarely. We are involved in several projects. We assess, we prepare, we package, we prospect. This is to show you our phased approach at Africa Health Business on the malaria projects that we continuously engage in. And we look forward to working with many partners who are here today and want to embed the private sector role in making a difference in malaria in Africa. Thank you so much for the time.
Oh, thank you very much, my brother. Really inspiring about
how well our resources being used. And number 5, impact. What difference does the intervention make? And number 6, sustainability. Respond to beneficiaries, global, country, and partner institution needs, policies, and priorities, and continue to do so if circumstances change. And for relevance, I think there are several different dimensions of relevance. First one is very general, relevance to whom? There are many people or the stakeholders engaged or involved in the malaria intervention, of course, like researchers, investigators. Many of you in the audience are researchers or investigators, but there are policymakers, program implementers, healthcare providers. They may be different perspectives and different expectations, and something relevant to one of the groups may not be as relevant for other groups. So that is important. And also, we always prioritize the relevance to the affected people, like Professor Kaseji or Professor Were mentioned. We have to talk to or listen to the voice of the people, but they're not homogeneous. So we need to be try to be as relevant as possible, but we have to think about relevance to whom. And then there's the issue of epidemiological relevance. Is the target area is highly endemic area or more seasonal transmission or near elevation? And then, of course, the issue of resistance is there. One of the examples I can share with you is our Satrex project in Laos. And Laos is pretty well advanced in terms of malaria control and near elimination, not near elimination, but very advanced in, relatively well advanced in malaria control. And only maybe the hard to reach population groups are left, like the loggers who regularly go into the forest and get infected. And in terms of the prevalent species, is predominant more, the Plasmodium vivax is more dominant, and so you have to deal with a very low level of parastemia. So you need to have a different strategy for detection. So those the context really define what to be prioritized in Laos. So the project is trying to address the country's specific needs through the project. And then thirdly, the ecological relevance is there, like what is the relationship with climate and also the vector mix and vector source. One example is that in Africa there used to be a phenomenon called a paddy paradox, which meant that if you compare the paddy, the rice cultivating community and non-rice cultivating community, you expect that the rice cultivating community will have a higher malaria burden. But in the past, it was actually the opposite. And the reason probably was because of the cash income gained from the rice cultivation. And then the communities in the paddy cultivation is actually have better access to malaria control measures. So the malaria burden was less, even though they have a higher density of vector. So, but if you look at according to the recent study, the paradox does not exist anymore, and the communities with the paddy field has the higher risk of malaria. So, because the JICA as a development agency promoting rice cultivation in many countries in Africa, we are really concerned about the paddy agriculture becoming the risk for malaria prevalence. So we are really looking into this ecological relevance as well. Of course, there's a socio-economic relevance with left behind and cultural relevance. And what is acceptable is really different. Even though the technology is superb, it may not be acceptable for various reasons. So that may not be really effective. The coherence, second is coherence. It is about compatibility of intervention with other interventions in the country or sector or maybe institution. because we are not operating in a vacuum. We have to always consider, even though we try to introduce something new ideas, try new tools, we have to always consider that there should be, first of all, internal coherence. The malaria-specific coherence with what is going on with the national malaria program, what is the intervention mix that is used in the specific areas. I think that is also important. But also, we have to consider external coherence, like the coherence with other health issues or other health challenges or programs, or even other development issues, like how the malaria control can be nested in a broader program of health system strengthening toward the universal health coverage, for example. I think that those are the considerations that we include. Like I said, with previously, the malaria is also affected by other development issues like agriculture, forestry, mining, because in our case, it is the loggers that are mainly affected by malaria, but in some other countries it is the miners. And again, there are some issues with illegality there. So that is also. Is it moving? Sorry. And then the issue of effectiveness, in order for the intervention to be effective, there should be a better prioritization, targeting. Also, but the effectiveness have to be measured to show the results and for the reason of better accountability, and also for the strategic communication with the stakeholders. And as the development partner, we are also looking into the effectiveness in terms of capacity development, whether the human resources and organization capacity or institutional capacity is developed through the interventions, the local, the country, the capacities. And then the issue of efficiency, whether the intervention or the program is cost effective, is it worth paying for, or increasingly many countries are introducing the formal way of assessing the newly introduced new technologies to be funded publicly, like the application of health technology assessment. So I think this the sense of cost effectiveness is also important. And then the issue of impact. Of course, the principal impact of malaria intervention should be the country's progress towards malaria elimination, or how better the malaria is controlled. But the impact can go beyond malaria and health, like non-health impact, like education, productivity, and things like that. And also there should be a scientific value, like innovation or technical breakthrough. And also we are looking into intervention more specifically address the local context. We also expect that lesson have some global implication as well, to be applied for countries and settings, the similar settings like epidemiological, ecological conditions. And then the sustainability comes in. There's always different aspects of sustainability, like technical, institutional, economic, and political. All of them are actually important, and all the development partners are expecting that even after the termination or the completion of the assistance, and that program to continue or even to be scaled up. Amit mentioned about the transition from donorship to ownership. I think that is really important for the program to be sustainable. One good example I can share with you is another such project which was jointly conducted by the Nagasaki University and also the researchers in South Africa. They used the climate model to predict the malaria incident. And then they developed a quite accurate prediction model. And now the project has been completed several years ago, but now South African researchers and the group of people are trying to establish a research alliance for climate and health, and then they are talking about how to continue the work through their own funding and through their own activities. I think that is a very good example of sustainability in short. So those are the 6 criteria that the Development Assistance Committee of the OECD uses for evaluating ODA programs. I think that is relevant for evaluating also the designing the malaria control and malaria interventions and programs. We over the years working in JICA, I had the privilege of working with prominent professors and specialists both from Japan and African countries, and I have learned a lot from their knowledge and wisdom. But sometimes I noticed that we share the same issue, we share the same, we see the same problem, we share the same concern, but oftentimes we speak a different language. And there should be a better way of communicating and linking, the development partner perspective like we have, and then the research community or the academics. Apologies if my slide is not operated very well.
Okay, yeah, thank you very much, Iko-san. Thank you very much for your very important talk on the role of partners, related partners. Thank you very much. So our last speaker goes to Dr. Haruo Watanabe, Japan Agency for Medical Research and Development, host organizer, about talking about the social transformation of MED projects, satellites and NTDs against control of infectious diseases in Africa. So Haruo Sensei, floor is yours.
Thank you very much. Please give my slide on that novel.
Organizer, can you present Haruo Sensei's presentation?
Yes. Thank you, giving me for an opportunity to introduce the MED project for the control of infectious disease in this symposium. Next slide, please. WHO reports an outbreak of infectious diseases that requires an international response of the state, namely public health emergency of international concerns. In the last 10 years, declaration of state has been issued for the 7 diseases listed here, such as the novel influenza, Ebola, polio, Zika virus, COVID-19, and the monkeypox. Although no state declaration has been issued, there are many communal diseases such as SARS, MERS, and drug-resistant bacterial infection, and others. Such infectious diseases spread across national borders. Its control requires international cooperation and a response. Next, please. Next variety of ways. Here are three policies of Japan science technology diplomacy for the contribution to the control of global issues. One is to work or take the lead under the international political framework, such as nations. And the second is to transfer science technology of Japan to partner countries, especially developing countries, and jointly respond to global issues. Third is a new response. Scientists from both Japan and partner countries conduct research and development to solve problems and transfer the result to issues. List of satellites and NCDs that I was told about is representative. Next slide, please. I will explain the fact of this project. SATEC is an organization for the Science and Technology Research Partnership for Sustainable Development. It is to conduct joint research between Japan and the partner countries for the solutions on issues that pose international problems. Four kinds of areas of international issue are listed here. One is for the control of infectious diseases, and the second is for response to environment problems such as global warming. The third is for the utilization of the biological resources, and fourth is for the control of natural disasters. Among them, AMED and JICA will jointly provide a research fund for the study of infectious diseases. AMED will provide a research fund to Japan side, and JICA will provide a fund to the partner country to carry out research. First is to build up a win-win relationship between global issues and strengthen scientific. Third is to strengthen the country will be able to carry out research and development by their own and build a system that can be sustained and foster reproductive programs. Next slide, please. This slide shows the partner countries of SATEC projects that have been carried out so far. As shown here, collaborative research has been conducted in many countries in Africa, Asia, and Latin America. Next slide, please. The NTD's Neglected Tropical Diseases project was proposed by the Prime Minister Abe at the G7 summit in 2016. It is dedicated to supporting international scientific research for the control of NTDs. Next slide, please. I'm going to document the project of satellites and NTDs as being carried out in Africa. First, show 6 representative projects of satellites. Target countries include Republic of South America, South Africa, Democratic Republic of Congo, Ghana, Gabon, Republic of Kenya. And target disease including malaria, zoonotic virus diseases, their pathogens, and schistosomiasis. Next slide, please. This slide shows the 5 NPD projects that have been conducted so far. Target countries include Pan-Africa, Zambia, Burkina Faso, Republic of Cote d'Ivoire, and Sudan. The target diseases including general NPDs, integrate vector management in diseases such as Bruni, ulcer, and mycetoma. As I have introduced, you have to understand that many countries in Africa have conducted joint research with Japan, and the disease that we have targeted are currently programmed in Africa. Next slide, please. I outlined the goals of the outcome of some successful projects. This slide shows you the joint research project between us. The purpose of this project is to use the meteorological science to forecast rainfall and predict in advance the occurrence of mosquito-borne infectious disease such as malaria. By predicting rainfall, temperature, and so on in the target area using a weather model, it is possible to estimate when malaria-carrying mosquitoes will emerge. If this can be predicted, it will be possible to implement countermeasures such as spraying insecticides to exterminate malaria-carrying mosquitoes, ultimately reducing the incidence of malaria. It was shown that this model can actually predict the occurrence of malaria outbreak in 2016 to 2017, 3 months in advance. This method is being used as a malaria early warning system in collaboration with the local government in South Africa. Next slide, please. This is a joint study of Hokkaido University, Zambia, and Democratic Republic of Congo, and it is an epidemiological analysis of zoonotic virus infections, in particular virus infections that cause hemorrhagic fevers such as Ebola, Crimea-Congo hemorrhagic fever, were targeted. By detecting virus DNA and antibodies, actual state of infection in wild animals, domestic animals, and humans were graphed. It is noteworthy that a simple Ebola detection kit was developed, and its effectiveness was demonstrated by patient error. Based on the result, the diagnostic agent was approved by the Japan PMDA, and preparations for WHO approval are underway. It is expected that it will be actually used in African countries where the Ebola outbreak is just over. Next slide, please. This is the joint research between Japan and Ghana was carried out to understand the actual conditions. Human African trypanosoma were investigated. Thermal amplification method, so-called LAMP, for diagnosis. Using such diagnostic kit, they conducted a local epidemiological survey and clarified the actual situation of the diseases. The information was provided to the government and tried for the countermeasures. Next slide, please. GK University has been conducted a joint research with Burkina Faso to promote research on dengue virus vector mosquitoes. They newly developed a viral DNA detection system to identify vector mosquitoes carrying the dengue virus, and they also developed new kind of repellent. It is expected to contribute to the reduction of dengue-carrying mosquitoes in the region. Next slide, please. As I introduced the SATEC and the NTD project, we have achieved valuable results. I'd like to emphasize two things. First, the social applications. We have developed a simple and inexpensive diagnostic method and made it available in the field in Africa. Several diagnostic methods are in use in the field, and efforts are being made to be obtained WHO approval. Second, epidemiological information is shared with the governmental authorities, and it is utilized for the implementation of infectious disease control in each country. The other important point of this joint project is human resource development. I'd like to emphasize that the potential young African researchers have been nurtured through this joint research project. It is hoped that these young researchers will play an active role as leaders in African countries in near future. Next, please. The project is scheduled to end in 5 years. Japan and African countries require to maintain and promote the joint research system that has been established in the SATEC and the NTD. The project has been contributed to the control of infectious diseases and maintenance of people's health. Final slide, please. As an IML project supervisor, I believe that the project in the SATEC and NTD will continue to produce the promising results under the joint research between Africa and Japan for the control of infectious disease prevailing in Africa. Thank you very much for your attention. Thank you.
Thank you very much, Hado Sensei, for your great and concrete presentation. Thank you very much. I think time flies like an arrow, so we don't have any time for a Q&A session. However, we have heard about community, private sector, development partner, and research funding agencies' perspective on the social transformation by the evidence. And also this is end of session 7, and also from research evidence towards social transformation in Africa. We hope to have new age Africa in near future. Thank you very much. Thank you very much for all the speakers. Thank you very much.
Thank you very much. Erokamano, Professor Tomohiko, for leading so that we get feedback. Please pass over the microphone to Prof.
I actually wanted to express appreciation for Dr. Sukishita. At the time he was in Kenya, he had a very positive influence on the scientists of Kenya in terms of strengthening their capacity as research scientists. So I just wanted to express appreciation to Dr. Sukishita for his role in strengthening the professional capacity of Kenyan researchers while he was in Kenya working here for some years. Thank you very much, Dr. Sukishita.
Thank you. Did you hear your question? don't think that. Okay. She's probably preparing to respond to that. But yours was a comment, more like a comment than a question, the appreciation. Thank you. There's a mic there, please.
Yes.
Go ahead.
Thank you, overall chairperson. And I would like to thank Prof. there for a wonderful job and for the presenters. Mine again is to just make a proposal on how best we can make use of the wealth of research work and good findings that we have that have been actually showcased in the presentations. I think from where I sit, it is important to have, to make efforts to pull this information, to pull all the evidence, the papers, the researches that we're doing in different fields into a hub where this can be easily accessed within our region, accessed by the different people who may need to use this information. And I also would like to propose, so what I'm proposing in a way is, Prof. Collins, I don't know whether this is something that the universities can do, to create a hub in the region. I don't know whether it's already there, but where all this information can be accessed easily. Yes. Most of this information is out there in publications. Some of us can't access these publications. Yes. The hub would be good for our scientists, the policymakers, and the researchers, for example, from national parliaments. Yeah. They really hunt for this information and can't get it. And the second thing is to also, as we pull these very deep scientific papers into a hub where it can be accessed, let's also have the easy to understand summaries of this very deep
layman's language.
Yes. So what does it mean? What does SATRIP? For example, how is the region benefiting? Yes. For example, I'm from the region, but it is in Kenya, but can Uganda benefit? So this is the kind of proposal I would like to put forward as moving forward from this symposium as a way to make sure that the research actually translates and helps in policy development and program implementation and actually move us towards eliminating malaria from this region. Thank you very much.
Thank you. Yeah, I think most of, since I think 2 years ago, as researchers, we are being forced to publish our papers in open access, where everyone can access it. That's number one. And then number two, every time we write a paper, they request us to give them a summary in a layman's language, so that if I'm in genetics and I'm talking about too much genetics, then they ask me, whatever you said in your genetic paper, now put it in a layman's language, so that we're able to move that research to policy to action agenda, and people are able to synthesize what you are talking about. And if they want to assemble evidence or data to advise policy making process, then they're able to quickly access it. But I fully agree with you that a hub need to be created where most of these things need to be deposited, because most of the time, all this research sometimes will not end up in a publication. Sometimes they even end up in reports, which you cannot access very easily. So I think that can come under the recommendation for this session, so that as the organizers synthesize through the recommendation per session, this can be one of them, so that we are able to pick them up and follow up aggressively and see the output of this particular symposium. So I fully agree. Thank you. Do we have any? Yes, there the mic, please. Pass the mic to Dr. Tierney.
No, thank you so much. Now, I'd like to comment about the open data access. Now, it's almost mandatory for all researchers to share their data under the open access data policy. So it's up to us looking at this information voluntarily for open access. So this information can be found online. Now, I have a question. This is just an open question for our community, as our friend is suggesting the other side. And it's a very simple one. Now, every country has their own policy in terms of, test and treat. Now, what do you people as scientists encourage or determine or do out there in the field when you have asymptomatic cases of malaria? Do you still stick on treating them or leaving them to stay the way they are so as not to interfere with their immune status? Thank you.
I don't know who will be responding to that. Whom are you directing that question to?
That's interesting. I think we have colleagues from Tanzania. I saw some friends from Tanzania. Then we also have many of our colleagues from the county Department of Health. I can see them around. So, yeah, sure.
Yeah, coming to your question, I think there's no specific guidelines on how to deal with maybe individuals, you cannot call them patients or participants of the study who have a symptomatic infection, but the rule of thumb is to treat them or observe them during the follow-up until they get symptoms. Maybe if you are doing a study which you have to follow up until to study something, then you can follow up. But in clinical trials of antimalarial drugs, any participant with infection, even if there's no fever, must be treated. So it depends a lot on what are you aiming for.
We are moving towards elimination. Now, these asymptomatic cases are the best reservoirs of malaria in our specific community, and you are meeting many of these cases. What do you do in this case? What's the police saying about this? Because I think if you listen to all our presenters, we are now focusing on the community. We want to see the impact of all these researches on how to save a life. The other day I listened back in estimate, and this old man told us, I'm giving you all these billions of money. You are telling me about molecules and all these things. Can you translate this information to simple English? How many lives did you save with the dollars I gave you? Period. Thank you.
So I think the clear with malaria infection, they are asymptomatic. We are also, now there are programs for school children. So if there's a special program, then they receive antimalarials. Then it was also the saying that asymptomatic is also with inverted commas. Most of these asymptomatics, they develop fever very soon, unless they're very low parasitemia. If you go to a school, you find kids with malaria and they take temperature. Some of them will find they are febrile, but they are still praying. So asymptomatic is also with inverted commas. It's not very clear when you say asymptomatic. Some of them, they develop symptoms before even you leave them. After taking blood sample, then you find them they have fever. Yeah, I think some people in the field, they can also support that.
Yeah, I think the question which we might not address in this meeting is, if we give you $100,000 to perform an intervention, if I come after 3 months, are you able to tell me this is what I saved, period? That's what a layman wants to know. Not the SARS part where, you go around in circles and then if I gave you 100,000 today and told you, use it in your hospital to perform an intervention, if I come after 3 months, are you able to list down and tell me, these are the interventions that I did, these are the lives that I saved, this is what I did,
No, in a short period, it will be difficult. Maybe Akira can say what he has done.
Pass the mic to Prof. Prof want to say something.
I have two comments. The first one is about whether to treat symptomatic cases. Always better to treat, because unless you are directly observing them to know whether they will develop clinical cases, there is always a risk not to treat. because most of our patients don't come back. We lose contact with them, and so my personal recommendation is that we treat. But I think this should be discussed by every Ministry of Health in our countries and give a general guidance.
Sure.
Regarding showing how many people you have saved, that is a difficult and possibly a dangerous direction, because it links help to curative issues. You cannot cure when you are promoting. And we are interested in promoting health and preventing disease. So you can do epidemiological, statistical analysis and say, epidemiologically, from this prevalence to this prevalence, it implies that we have saved so many people. But you can't really say, I have saved so many people, unless you are dealing with curative medicine. And that is not necessarily an approach to promote healthy well-being.
Let's hear the last comment, because we have comment or question.
Yeah, thank you.
Is that a comment or a question?
Both. My name is Dr. Laktabai from Moi University and Ampath. Thank you to the presenters. Yeah, I wanted to support what Prof has said, that it's better to treat the asymptomatic cases. I think the last review I did showed, I think there's evidence that even among the asymptomatic, there is background hemolysis going on. So really, at the end of the day, you'll have to treat everybody. And I think, as a professor from Tanzania was saying, in pregnancy, we really treat them. And we are shortly rolling out a malaria in pregnancy intervention, basically looking at asymptomatic malaria in pregnancy, submicroscopic in Kenya and DR Congo, and treating them and basically following them to see whether there's a difference in our outcomes, and hopefully some of those become evidences. I wanted to show data, and we have all said that there is open access, but I think the translation of the information into practice requires a different approach, more than just depositing publications into one repository and say, from the evidence of the primary researchers, because they are considering primary data from our different researchers, there needs to be somebody who is mining data from the individual researchers, because I don't think we have researchers who have that either time or resources. So maybe there needs to be a translation committee that is receiving all this data and synthesizing them scientifically, then translating them into policy. And my thinking is that they are trying to spread the gospel of bioethics, and I think we need to put more money in bring up to speed our researchers into being ethical. In human, we must embrace ethics.
Called responsible conduct of research, RCR, and I think, you raise a very important point. Having that discussion in every symposium or workshop or conference, ARBs, and it's usually a big challenge how researchers try to circumvent, go around corners. So it's important that we bring that up again in the end. I think that should be one of the recommendations for this. Thank you. Please allow me to the video. Why are you switching me off when I'm talking about the video? So there's a video. I remember malaria and other parasitic diseases from Kigali, Rwanda. It's about here, so this is our last session. So I'm requesting that if we can just listen through the video. The summary session. Yes, there's a summary session, of course. So the keynote, the rapporteur, please just prepare your key points for the summary session. So
so that we will be able to go through that session. This was for the co-chairs, session co-chairs. So we'll need the key points, maybe key 3 to 5 points that you feel came out from each session, so that we're able to make progress.
My names are Dr. Marwan Chumreni. I'm the Rwanda National Malaria Control Program Manager from 2016, and it's a pleasure to share with you this afternoon malaria situation in Rwanda, but mainly focusing on the progress to malaria elimination in Rwanda. I'll start with sharing with you this structure of the health sector. As you can see from the left side, we have a country divided into 5 provinces, and under those 5 provinces we have 30 administrative districts, under which we have sectors, and below sectors we have cells, and below cells we have villages, and in the middle we see that we have referral hospitals, we have provincial hospitals. In each province we have at least 1 provincial hospital, except in Kigali City where we have only referral and teaching hospitals. We also have some specialized hospitals, such as referral for mental health or cancer treatment, etc. But very key, you can see that at each district we have at least 1 district hospital, and in some districts you may even have more than 1 district hospital, given the geographical accessibility, because sometimes we need more than 1 hospital per district. Below the district we have those medicalized health centers. Those are new. They are well equipped to support hospitals. We have medical doctors, and they can perform some tasks so that some patients may not need to go far from village to the hospital. They can just go to those medicalized health centers. For the health centers, these are corresponding to the sectors, and you see those are run by nurses. They have other technical staff, including lab technician, and most of malaria cases are managed from the health centers to community level. And recently, the government started putting in place another layer of health posts. And these are mainly private, but some of them may be public health posts. They are also run by nurses, and they can provide an advanced package compared to the community health workers here below. Countrywide, so far, we have around 60,000 community health workers, and those are the ones dedicated to manage malaria cases, but also other specific diseases. When you look at the malaria epidemiology, on the left side you can see that malaria incidence per sector is very high in eastern part of the country, bordering Tanzania, Burundi, but also near DRC, where we have those dark zones having more than 450 cases per 1,000 as malaria incidence. And this was corresponding in 2016 to the high burden zones. And we have a clear justification for that, because we have water bodies there, high temperature in the eastern part of the country, but also you can see those water bodies in green corresponding to rice cultivation areas, and these are contributing to mosquito density increase. You can also easily see those red dots corresponding to the documented mosquito resistant to predatory. That also can justify that why in those dark zones we have the high incidence, because interventions that were deployed there for malaria prevention, like a standard net, were not working perfectly due to that documented mosquito-resistant pyrethroid. We have other factors like mining activities, and those are mainly run next to Kivu Lake, but also some in northern part of the country. And these are also factors that are contributing to the creation of water bodies around our communities, and the mosquitoes are breeding there and contributing to malaria increase in some specific areas. This was in 2016, and you can see on the left side, after 5 years of sustained interventions, you see that almost all sectors are now in yellow, below 100 per 1,000 as incidence, meaning that sustained interventions for malaria prevention are producing good results, and almost everywhere for pregnant at least. How in cases and incidents, reaching that peak in 2016-17. From there, effort is put in. And you can see that a drop from around 17, 18. The same trend is also seen for mortality due to malaria. The same with sustained indoor interventions. And recently, around those rice farms. Identified can represent they get infected later. They are progressing very quickly to severe malaria and why not to mortality due to malaria. And people are also non we are currently deployed. Sustain is very key, but of course, we need to continue deploying evidence-guided interventions.
Yeah, because that was a video, there was no way I was going to say is spent a little bit over time and he need to summarize. So he got away with that. But thank you so much for that presentation. Because we are really running out of time and you can see the room is getting empty, I know our online participants are also getting exhausted. They also want to finish up. I want to take this opportunity to request the session chairs just to give us, as I said, 3 key recommendations from those sessions that they noted. And I hope if the session chairs are not here, their respective rapporteur are able to pinpoint those key. Because if we have too many recommendations, then we know for sure that they'll never be picked up and implemented. That's why share the microphone. The other one. Yeah, the other one. The other one. So for session 1 on policy on malaria control.
But are you going to put the slides on Zoom? Yeah. So yeah, we're very behind time, so we will not go over the summary slides. We'll email it to you, and
sure.
If you have comments or have questions related to each of the sessions, we can reach back to the session chairs and go through that. But I just wanted to.
So you are presenting for the whole sessions, from session 1 to.
Yeah, that's what I was supposed to do.
Sure. I just wanted to be sure. Yeah, sure.
May I?
That will save us time actually. Please go ahead.
So the plan was to share the summary slides with all of you, and and read the slides and get clarification on the questions needed. But since we are behind time, we're not going to do that. We'll email it to you, and then you can provide a update on that. So the next thing is the symposium. Several of us will be working on synthesizing all the speakers, talks and so on and so forth, and then. After we have an outline of what papers might come out from the proceedings, we will call for authorships. We hope this can be led by institutions here in Sub-Saharan Africa. It would be great. I think we have a lot of postdocs, we have a lot of PhD students. I hope they would be able to lead this effort. Of course, and we are always happy to support that. The release timeline, we have not really discussed that, so perhaps World Malaria Day, I think that gives us some time to finish writing. And we'll also coordinate with the East African community and other institutions here with regards to the publication of the proceedings. And next slide is just a big round of applause to this invisible. Thank you.
That was fast. Thank you, Dr. Chut. Thank you so much. There are 2 things I want to say. First of all, I want to thank every process. We really appreciate whether Professor Akira Kaneko to award and I can help you with that process. But please, you can say the last closing remarks.
We have done so long 2 days. So all Professor Miriam Were and all speakers online and in person, and all participants. Thank you very much for your active contribution. And especially, I like to say thanks to Professor Collins and his team in Maseno University for their big contribution. And also, Kato-san, どうもありがとうございました。Thank you very much. エルカマのメルシーボック、Thank you very much. ありがとうございます。そう、ありがとうございます。Yes. So have a nice journey, and this is not the last, but the beginning of new collaboration, and we hope to see you again soon. Thank you very much.
Thank you. So before we got the certificate, I wanted to $5.50, and then the other will be $5.45. So please just fit into those two trips so that we are able to manage, because there are 9 people going to the airport. It's not 5. Even if you miss the 5:15 one, they'll still run you up at 5:45. But let's try to organize ourselves into those 2 groups. Of course, there's a group which already left for the airport now. Having said that, I want to take this opportunity to request Professor Kira Kaneko and Dr. Jesse to kindly step forward